In March 2026, NASA announced $20 billion over the next 7 years to build the first permanent human base on the Moon. 3 uncrewed missions launch before the end of this year alone. At the same time, the Artemis program has already burned through more than $100 billion and years of delays. And China and Russia are building a rival station with a nuclear reactor on the same rough timeline. This isn't, "Are we going back to the Moon anymore?" Humans already did that 6 times, more than 50 years ago. This is, who actually stays? In the next 9 minutes, why the South Pole specifically, how you actually build something permanent up there, who's racing to do it, what keeps going wrong, and where this really ends up. Apollo put boots on the Moon. 6 times for a few days each, then home. Every gram of water, air, and fuel came from Earth, and none of it stayed behind. A permanent base is a completely different problem. Infrastructure that keeps people alive for months, then years, not a long weekend, without a resupply ship every single time. The South Pole matters because of what's sitting in its permanently shadowed craters, spots sunlight has not touched in billions of years. Water ice. That ice can become rocket fuel and breathable oxygen, mined and processed right there, instead of shipped from Earth at enormous cost. Every extra kilogram launched from Earth means another rocket, another risk, another line item on an already massive budget. Here's the actual quote that frames why this is happening now, from NASA's own administrator, Jared Isaacman. "The clock is running in this great power competition, and success or failure will be measured in months, not years." That's not marketing language. That's the head of NASA saying on the record that this is a race. So how do you actually turn a pile of ice into a livable outpost? The core technique is called ISRU, in-situ resource utilization. Use what's already there instead of hauling everything from Earth. It sounds simple. Doing it reliably, on a world with no atmosphere and temperatures that swing hundreds of degrees, is not. Melt the ice, split the water into hydrogen and oxygen. Hydrogen becomes fuel, oxygen becomes air, or more fuel. Picking the actual spot depends on sunlight for power, survivable temperatures, a clean line of communication to Earth, and how close the ice really is. Get any one of those wrong, and the base can't sustain itself. The leading candidates are the rim of Shackleton Crater, which may hold the most abundant ice deposits, and a flat-topped mountain called Mons Mouton, which stays lit by the sun almost constantly. NASA's plan runs in 3 phases. Phase 1, this year. Moon Base the One, launching this fall on Blue Origin's Blue Moon Mark 1 lander, nicknamed Endurance, delivering the first critical equipment before a single astronaut sets foot there. Phase 2, from 2029 into the early 2030s, permanent infrastructure, including an actual power grid, the difference between a campsite and something that can run itself. The target for a continuously staffed base, 2032. That's 6 years away for something no country has ever actually managed to do. So who's racing to get there first, and how far along is everyone? NASA calls its plan Project Ignition. $20 billion, 7 years, backed by nearly $1 billion just for this year's 3 launches. SpaceX and Blue Origin are building the actual human landers, versions of Starship and Blue Moon big enough to carry astronauts, not just cargo. In February 2026, NASA restructured the whole plan. Artemis 3 became a docking demonstration instead of a landing, and the actual crewed touchdown moved to Artemis 4. Target now, Artemis 3 demo around mid-2027, boots on the ground as soon as 2028. Meanwhile, China and Russia are building their own outpost, the International Lunar Research Station, in 3 phases. Reconnaissance through 2025, construction from now through 2035, and utilization starting in 2036. China's Chang'e 7 launches later this year, hunting for water at the South Pole. Chang'e 8 follows in 2028, actually testing the construction technology a real base would need. China and Russia signed an agreement to put an actual nuclear reactor on the lunar surface, targeted for 2033 to 2035, to power the station once it's built. Their stated long-term goal: 500 research institutions and 5,000 researchers involved by 2035, expanding further by 2045. So with all that money and planning, what's actually breaking? Start with the number that should stop you. The rocket alone, SLS, has already cost more than $23 billion to develop and about $2 billion every time it flies. A 2021 government audit put the entire Artemis program at $93 billion through 2025. Isaac Mann himself confirmed the real number has now passed $100 billion. BSFR, that's an enormous amount to show for a program that still hasn't landed a single crewed mission back on the surface. Some of that comes from years of loose oversight on the rocket's main contractor, Boeing, flagged repeatedly by NASA's own Inspector General for schedule slips and contract extensions, with barely any accountability attached. Artemis II alone slipped twice in early 2026, hydrogen leaks during fueling tests in February and March, before it finally launched on April 1st. And the political ground isn't stable either. The White House's own 2026 budget proposal suggested retiring SLS and Orion completely after Artemis III in favor of cheaper commercial systems. If that funding gets pulled again, the whole 2032 timeline is straight up chopped. Isaac Mann's own words on the difficulty ahead. Extremely difficult, in fact, near impossible, is what the American people should expect. Then there's the moon itself. Lunar dust is sharp, magnetic, and genuinely toxic on contact. It gave Apollo astronauts coughing fits and eye irritation just from tracking it into the cabin on their boots. And radiation up there needs a couple of meters of solid shielding before it's safe to live behind, thick enough to soak up cosmic radiation before it ever reaches a human body. So zoom out. Where does all of this actually land? If NASA's plan holds, continuous human presence at the lunar South Pole by 2032. That is faster than NASA has ever moved on anything this complex, and faster than this exact program has managed so far. China and Russia are targeting a working outpost by 2035, two completely separate camps, chasing almost the exact same finish line with almost no coordination between them. Isaac Mann ties it directly to the next step. In his own words, "We have a moon base to build, a nuclear spacecraft to launch to Mars, and all the science and discovery that comes along with these inspiring endeavors." The moon isn't really the final destination here. It's the proving ground for Mars, and everyone involved is standing on business about that part. This is genuinely a race on two separate fronts at once. A technical one, whether ISRU actually works at the scale a real base needs, and a political one, whether the funding survives the next budget fight, the next administration, the next headline about cost overruns. Two countries, same decade, same finish line, different flags. So, is humanity actually going back to stay this time? The money says yes. The history of this exact program says, ask again in a year. If this one got you thinking, follow the channel. The next mini-documentary comes with the same real, sourced data, no hype either direction.